So if you could just bear with me, I'm going to do some drawing, and you know how that works. So follow along as best you can in your notes. Maybe give it a page. Call it orbits, if you please. And we'll recall back to some things as we go. I'm going to draw one circle, call it Earth. Draw another circle, call it the moon. And we'll say that the moon does what with the Earth? It orbits around it. Very good. It's almost like you guys had first grade. Probably Daniel Tiger probably talked about this, right? Earth and moon. Okay, all right, okay. I'm sorry I mentioned it. Oh, man. Bring it back.
We're drawing that. The Earth in the middle, the moon, and it orbits.
Do we need to draw that?
Yeah, please. Yes, please, draw that in your notes. And then we're going to write on it. It's a very crude picture. I apologize. You guys know by now I'm not much of an artist. Okay, so now check it out. If you remember Newton's first law of motion, do we remember Newton's first law of motion? No? Can somebody remind us? Nobody can remind us. Something about what? It's the law of inertia. What is that? Go.
Something will always be in motion unless
So an object, for example, the moon, will be in motion unless some sort of force stops it or changes it, right? So I think I simplified it and said, listen, objects will keep doing what they're doing unless something stops or changes what they're doing. Does that make sense? That's the law of inertia. So the moon, we think, well, what is it doing? It's orbiting the Earth. Is it wanting to keep doing that? What if I were to tell you that the moon actually wants to fly away? So when we think about Newtonian physics and Newton's first law, objects don't want to curve. If they're moving, they want to keep moving in the direction they're moving at a particular moment in time, which means the moon wants to move in a straight line. And we would call that linear momentum. It wants to just keep right on going. It's going to fly away from the Earth. What keeps it from doing that? Which is he said gravity keeps the moon from flying away. What is gravity? It's a force. So Newton's first law, an object will keep doing what it's doing unless acted upon by a force, an unbalanced force. So the force, the momentum that the moon is trying to travel is impacted enough by the gravitational attraction between these two bodies to keep it from flying off. If we increase the momentum by increasing the mass or by increasing the speed, it could fly away. By the way, spoiler alert, it is actually, the orbit is getting further away on average every year. That's neither here nor there. So we have gravity pulling toward a center of mass between the two objects. They're both gravitational bodies, but the gravitational center of mass is actually inside of the Earth. I can't remember exactly how far from the axis it is. It's out somewhere in the mantle, I believe. I'd have to look it up. So they actually orbit that center of mass. Does that make sense? Both of them do. What else? So we have gravity trying to pull the moon down to make it fall, right? And we have the moon's momentum wanting it to pull it in a straight line. Not pull it in a straight line, but just keep traveling in a straight line away. And then we have the actual orbital path that it is truly traveling on. So if we wanted to do a bunch of math, And I think we don't, right? You do. Who does? Oh, you don't. If you want to, I can point you in the right direction for some of this math, okay? But without using numbers, we can explain that there is an angle here, okay? This angle between the linear momentum, that line that the moon would travel on if not for the force of gravity, and the orbital path, there is an angle, okay? That measurement goes into what is called the thing that is called angular momentum. Okay, so when we're describing Earth's orbit around the sun, the moon's orbit around the Earth, we could even describe the sun's orbit around the... What does the sun orbit?
The Earth.
What does the sun orbit? The center of the Milky Way galaxy. The center of mass, which, by the way, is a what? A black hole, a supermassive black hole at the center of our galaxy. That is the center of mass. It's the point about which everything else revolves, right? So now we could take it a step further if we wanted to. Angular momentum helps us understand the orbit, why things orbit instead of just flying off. It's that balance between gravity and linear momentum. So in your notes, if you want to, for today, you could just put down rock cycle. And before that, abiotic versus biotic. Do you guys remember that terminology? Yeah. Did I just give you like bad memories? Yeah. Okay. So the Earth part of this, the like more recall type learning that you've already done most of this, you guys. Abiotic versus biotic cycles. So for abiotic cycles, the rock cycle, the water cycle. For biotic cycles, carbon cycle, nitrogen cycle. I think we could categorize it that way. Not to say there's not some overlap. Life can affect the rock cycle, right? Life can affect and be part of the water cycle. Think transpiration, right? We'll get to that when we cover the water cycle. Let's start today, though, with the rock cycle, because it's the first one on my list, not any other reason. And once we get through all these cycles, though, and talk a little bit about ecology and whatever, then we'll be able to use what we've reviewed, because all this should be reviewed, most of it, for like, so what? That question, so what? It's actually more of a statement, what, or a thing even. What is a so what? It's a reason, right? So why should we care about all this stuff we're learning? Well, it really comes down to what we need as people, yes? Or as a civilization. What do we need from the Earth? And then are there impacts that we might have on the Earth that would be detrimental to us in the long run? Make sense? Okay. Which I'm sure you've heard some things about before. So rock cycle in your notes. So to understand the rock cycle, we need to understand a bit about the types of rock. This is so exciting. How many of you all actually do like some geology, some rock stuff? Okay, cool. How many of you are all like, yay, rocks? So there's three main types, right? Can you remember the three main types? Sedimentary? I heard sedimentary. Okay, I hear igneous. It does not have to be in a certain order. And then you have what? Not Mediterranean, although you might find some in the Mediterranean region. What? Metamorphic. All right, these are your three main categories of rock types. Igneous rock has two subcategories that I want you to look at too. Okay? I want you to do a little bit of refreshing on your own I want you to define each type. So look it up if you have to. If you remember, that's great. That's great. So you're going to define each type and provide examples. And then we can talk about how it works with the cycle. Does that make sense? Okay, so define it first, give me some examples, and then we'll talk about the cycle itself. Go. And maybe like an example or two of one that you already knew about, and then maybe one that you didn't know about, and go down a rabbit hole, here or there, and learn something. What? A couple at least, right? I would say like maybe 2 for each of the subcategories of igneous, and then maybe 3 for each of these. I'm just trying to refresh your memory of what they are. Giving examples helps. All right, everybody ready to go over? If you're missing a spot or two, we'll fill it in, okay? Igneous, what do you have for a definition? A nice, simple, easy definition. Someone, go.
Solidified from water and magma.
Okay. Solidified. If I can spell, I can't spell. From either what or what? Lava or magma. What's the difference, do we remember, between lava and magma? So this is in crust, and this is out of crust, right? In other words, this didn't erupt out of the surface. Lava did. Does that work for you? Okay. Now, if it erupts out of the crust, if it's lava solidifying, what kind of igneous rock is it?
External or
Extrusive. Is that right? Extrusive. If it didn't erupt out, if it was stayed magma and just cooled as magma, what do we call it? Intrusive. Good. All right, so maybe an example or two of each of these. What do you got? You got same person. Yes, go ahead.
Obsidian and basalts.
For extrusive, right?
Yeah.
Obsidian, and pardon my spelling, and basalt.
I think so.
Okay. And for intrusive? Jess. Granite and what?
Sill.
Spell it.
SILL.
What is that? Can you explain it? I don't know if I've heard that one. I'm not a geologist. Go ahead. Do you have another one that maybe I've heard of for intrusive? No? Maybe? Yes, no, maybe? No? All right, moving on. Sedimentary. Do we have a definition for sedimentary? It's rock made from bits of pre-existing rock or bits of living things. So look, sedimentary rock is made from sediment. Sediments are bits of stuff. So right now, I don't know if you've heard this before, but it hopefully makes sense to you. Right now, the sediments that are being laid down have traces of human things. Okay? So yeah, later on, some later civilization looking back through the sedimentary layers laying down right now will find evidence of human civilization to include things like plastics. Now, most of the plastics, it takes forever they still break down, but there'll be chemical traces of the plastics left behind in that layer. Yes?
I didn't even notice that.
So, sediment, if you don't have it in there already, write down sedimentary rock made from bits of previous rock or organisms. Examples would include limestone, and that's a good example of from previous living things, right? Because it's like highly calcified remains of sea creatures, the shells and whatnot, right? It's really chalky because of all the calcium. Give me another one. Clay? Yes. And if it's pressed into a stone. So clay by itself is, well, I've got a bunch of it in my backyard, right? Everybody around here's probably got a whole bunch of clay in their yard. We usually have like an inch or two, if you're lucky, of topsoil on top of clay. So anyway, clay can become a stone, yes. How about shale? Shale's pretty common around this part of Kentucky. Most of Kentucky. Limestone. Did you guys know, off topic here, but we got time. Did you know that one of the reasons this is such a important like horse area and so many good race horses, supposedly, I mean, this is something I heard, I hope it's not an urban myth, but the limestone that underlies our hay fields, because there's so much, it's calcium rich because of the limestone, the bones of the horses are stronger than a horse maybe raised somewhere else. Did you know that? Have you ever heard that? So there's a reason why horse culture is so big here. That's supposedly part of it. The limestone under our feet. Cool. Metamorphic definition. I have the same person volunteering every time. Bailey, what? Okay, so you've got an old rock, an igneous or sedimentary rock. It doesn't have to be that old. I mean, it could have been fairly recent. So you have igneous, if I can spell, igneous or sedimentary, pressed / heated, right? So under heat or pressure, heat and or pressure, and the type of metamorphic rock it becomes depends on what type of igneous rock it started as, what type of sedimentary rock it started as, and in presence of what? So, for example, was there water seeping in carrying other chemicals? Does that make sense? So, how much heat, how much pressure, what was the starting material, and what else got into it? Does that make sense? That's going to determine what specific type of metamorphic rock you end up with. Do we have some examples? Huh? Marble? Quartz? Or quartzite, right? I think. What do you got? Soapstone? Good? Anything else? Okay. Did we talk, well, I think we're good there. Rock cycle. So how does this work into the rock cycle? Quick discussion and then I think we'll be done. What could a metamorphic rock become? What? You think it could become either? So how would metamorphic rock become igneous rock? If it gets melted. So most common way for that to happen would be some subduction, right? So if it's subducted into the mantle, it could be remelted and recast, basically recycled as new igneous rock, okay? And of course it could break down by what? Erosion, weathering, right? So wind and rain, the freeze-thaw cycles could break metamorphic rock down into sedimentary rock. What can sedimentary rock become? How would it become metamorphic? The heat and pressure, right? That thing. Or could it become igneous? By being recycled again into the mantle, melted back down. What could igneous become? So heat and pressure becomes metamorphic, or break down by weathering to become sedimentary. So they have multiple paths to go through the cycle. Okay, questions on that? Did we go over abiotic and biotic? I swear I thought we did, but it's been a lot of classes today. We did? Okay. Can somebody give me an example of a biotic factor? Carbon by itself? Like in certain forms, right? So carbon, if it's part of a living thing or part of something that was living. Carbon dioxide, for example, is not considered biotic, even though it's carbon in it. I like that you said carbon right off the bat, because most things that have carbon in it are considered organic. Okay? So living or formerly living stuff is going to have carbon in it. And that also would fall into biotic. So biotic, you could also say organic. I was actually looking at one of these, what's biotic versus abiotic on the internet, pre-resources. And one of them says that soil is abiotic. But then on the biotic side, it says organic matter is biotic. Does that make sense to you? What is soil? Soil is a mixture of organic material and other sediments and other stuff into a soil. So if it's got organic material in it, by definition, doesn't that make soil also biotic? Absolutely. Absolutely. So anyway, biotic generally, anything organic. All life forms that we're aware of are organic, right? So living things and the material that living things left behind, either their dead bodies, decomposing bodies, or their poop, or whatever, all that's going to be biotic. Abiotic are things like the weather, right? Climate. I'm looking at my list now, I'm cheating. So stuff like water, okay? Unless you've got living things in it, I guess you can make an argument. The air. Are there microorganisms living in the air though too? Good gracious, I mean there's life everywhere. So, but stuff that doesn't have living things in it or things from living things in it are abiotic. Questions, comments, concerns?